a quick video, and I have time randomly. It's kind of hard to schedule, self-employed is self-employed. I think I'm going to be out of town February 1st through 5th, but back in town for the rest of February after that. Arduino Microcontrollers, built as an open source electronics prototyping platform. These are all different kinds of microcontrollers, different shapes. That's by far not the littlest. That's not the biggest. But this is the Arduino standard. And what it is these guys took a bunch of pieces and parts that you needed to make a microcontroller and integrated it into one standard platform. And they left it open source, so anybody can make copies or knockoffs, and they're all compatible with each other. Kind of like how PCs were 30 years ago, when anything was, quote, PC compatible. A microcontroller is super cheap. It's different from a microcomputer, which is a little bit more expensive and smarter, because it actually thinks and processes. A microcontroller takes a program that you write and repeats the same steps over and over and over again until you tell it to stop. So it can turn things on and off, it can read data, it can output data. It will do anything you tell it to. These are sensors, pieces, and parts that you can connect to a microcontroller. Totally just scratching the surface here. All these are gas sensors for different kinds of gas, whether it's carbon monoxide, ammonia, propane, butane, what have you. These are different temperature and humidity sensors, pressure, altitude. This is a servo motor. Actually, that is just a standard DC motor. Goes round and round. It can light up lights. It can turn lights on and off. It can make noise. These are little speakers. This is an ultrasonic rangefinder. It's the eyes for the robot that you can build and control and program with your microcontroller. You can set it to turn relays on and off based upon temperature. Say it hits 80 degrees in the classroom, it can turn a relay on, which turns the air conditioning on for you. You can put a Wi-Fi module on it and control it from anywhere in the world that has an internet connection. I have built camera rig robots that I control with apps that I have developed on my phone with pneumatic actuators. This is a Arduino Uno. It's a super small microcontroller. This is a relay board. You can use 5 volts of direct current, low power electricity to turn on big, giant, massive, high voltage AC machines. What do you want to turn on and turn off from anywhere based upon any set of parameters? They can control these lights. Each of these lights are controlled by its own individual integrated circuit and are all individually programmable. I wasn't really planning on a lesson plan today or this video, so I apologize for rambling, but these machines cost, you can pick up one of these boards for $10 and control your world with it. These are big stepper motors. They turn things, big heavy things, precisely. Again, I'll get a cool lesson plan together and a real example thing for the kids. But this is the quick intro, and this any of them can learn how to use and operate these things. And this is how, you've heard of the Internet of Things. This is how the Internet of Things is controlled. Microcontrollers, Arduinos. This is what puts the kids ahead, and I'm really excited about it. I wanted to go and kind of give them an intro to welding, but that's hard to do to a big class in a short period of time. This I can do, and in fact I'm using this to develop a smart welding hood that would allow welding to be taught easier. Okay, thanks for the 6 minutes. I'm not going to edit this or anything. I'm just going to kind of send it as is. And feel free to hit me up with questions, comments, concerns, whatever. But it's electronics, and it's an easy way to learn about electronics, and it's an easy way to learn about programming, and it's copy and paste. All the code's been written. You just have to learn how to look for it in the right places, and I'll show them how to do that. I'll get some Arduinos and donate them, and donate some sensors and kits and whatever to the school, so y'all can play with them there. And you don't need big fancy supercomputers or anything. Any computer with a freaking USB port, you can program Arduino. It's amazing. All right, later.